In this lecture, we are going to talk about the hardware elements of a control system. As a prelogue to this particular video, you can check my other video on measurement of process variables, where we talk about why at all we require to measure process variables of importance and how we classify them as either manipulated variables or controlled variables and so on. uh, in this lecture, particularly, you will get to know about the structure of a control system and what are the main elements which are used for measurement and for transmitting the measured signals. Now, the first hardware of interest is, of course, the chemical equipment. Let's say you have a reactor, or say you have a distillation column. So that is the chemical equipment or the process equipment. So about this particular equipment, obviously you read in different other subjects, like in mass transfer you learn about absorption columns and distillation columns and extraction units. In reaction engineering you learn about reactors of different types, like batch reactors. You can learn about plug flow reactors and so on. The other important elements, the most, the one of prime importance rather, is a sensor. So, what is the purpose of these sensors? Sensors are basically measuring instruments. So, what are some of the examples of measuring instruments? You can say thermocouple, which is used to measure temperature. Thermocouple is a measuring instrument. Then generally thermocouples are used for a quite low range of temperature. For very high temperature value, say if you are working in a unit where you have furnaces involved, then you would maybe use a radiation pyrometer. So these are for high temperature measurements. Then, to measure flow rates, you may be using a venturimeter. To measure composition, you can use gas chromatographs or some other form of composition analyzer. So, all of these fall under the category of measuring instruments or sensors. Now, our target is to have such sensors whose measurement can be readily transmitted in the form of some electric voltage or pneumatic signal or current. So, to transmit the actual change, say in thermocouple, you have a temperature change. In radiation parameter, you'll have a temperature change. In venturimeter, you'll have a flow rate change. So all these changes need to be transmitted in the form of voltage or current change or pneumatic change, that is some change in the air pressure. Only these pneumatic signals or electric signals are read by the controller. So next in line comes the transducers. These are the main converting elements. They actually convert measurements into useful signals. By useful signals, I simply mean the electrical signal or the pneumatic signal. For example, a very common example is a strain gauge. A strain gauge is used so that if there is any pressure measuring element where you can see a change in mechanical strain, then that change in pressure is converted to an electrical signal. So that is one of the very popular examples of transducers. There are many other examples. Maybe I'll elaborate on them in some other video, but this is the most basic example of a transducer. Now that you have measured and you have converted the actual signal, say a pressure signal, to the useful electrical or pneumatic signal. Now it is time to transmit the signal. So you require transmission lines. So what are these transmission lines? They basically carry, so you can call them carriers of signals. They'll carry the signal to the controller. Now they may or may not have amplifiers. The reason for using amplifiers is some of the signals that are actually generated by transducers are very weak, and you may need to amplify them if you want to transfer the signals over a large distance. So they may or may not come with an amplifier attached. The next step is a controller. So this is basically the heart of the control system. What it does is it is imparting the control action. So whatever logic is inbuilt or which is programmed into the controller, that is dictated simply in this hardware element. Then comes the final control element. What is the final control element? It is the one which implements the action. So controller has said that okay, I need to reduce the flow rate of a certain stream. Then the final control element, being a valve, will implement the control action. So the if the valve closes slightly, then the stream flow rate will reduce. So the best example is the valve. Other examples include relay switches. There are also variable speed pumps and compressors, which which implements the control action. So variable speed pumps are also used as final control element. After this, the next one which comes in line, which is basically the last one, is the recording element. So what does the recording element do? It visually demonstrates the process behavior. What do I mean by this? So say you have the process somewhere else in the plant, and you are sitting in the control room. So maybe you have a video display unit which shows how the pressure change is affecting a particular reactor and so on. So there is some video display unit which records the temperature change or the pressure change, which shows what kind of amplification is done in the transmission line and what the controller decides to be done with the necessary measurements that are coming through, and what the final control element finally implements as the control action. So everything together, all the seven elements, that is the process equipment, sensor, transducer, transmission lines, controller, and final control element, along with the recording element, comprises the entire hardware associated with the process control system. Now let us visualize this through a small example. Say you have a tank wherein there is a liquid and the height is h. There is an input flow rate, say F in, and there is an output flow rate, F out. Now my target is to maintain this height at a desired level. So to do that, this is basically the process equipment, that is the tank. Now the next step is to incorporate a measuring instrument. So somebody has to measure the level over here. So we will just simply fix a level height measurement, and that will record the actual height. So that can be done through some calibrations on the tank itself, and then it will be sent to a transducer which gives the level indicator. At this point, you can also input the idea of the desired level. Let me say L desired. So L act is the actual measured level, L desired is the required level, and Li indicates the difference. So this is a transducer element which will finally transmit through the transmission lines to the controller. Let me call it C. Now this controller will impart the action to, let's say, a valve in this F out. So just in case the L act, in case the L actual is going to exceed the desired level, then the output flow rate must be increased so that the original height is returned. In case the L act is lower than the desired height, then the output flow rate should be reduced. So the controller can simply impart to the control logic that if the level is higher than desired, then just open the valve a little more so that more of the liquid flows out and the actual level is attained. If not, then simply close the valve a little bit so that the actual height is increased to the desired level. So this in total comprises a process control system. I'll be attaching some of the useful references that I have used to create the content. You can refer to some of the popular books like Stephanopoulos. You can also refer to Coughanowr for further knowledge on these particular hardware elements. Till then, thank you.